The saga continues at 123 Main Street, where a century of electrical neglect has culminated in a homeowner's nightmare. The property exhibits a dangerous array of problems, ranging from fixtures hanging precariously by their wires to entire rooms without power. The root cause is a long history of haphazard electrical work, where circuits have been misidentified, neutrals are missing, and the entire system is essentially a ticking time bomb. Tackling this situation requires a systematic approach, prioritizing safety and adherence to electrical codes. Firstly, a comprehensive assessment of the existing electrical system is crucial. This involves meticulously tracing circuits, identifying miswired connections, and documenting all existing electrical errors. The goal is to create a detailed map of the current electrical layout, which will serve as a foundation for subsequent repairs and upgrades. Secondly, the integrity of the grounding system must be verified. A properly functioning grounding system is essential for preventing electrical shock and minimizing the risk of fire. This involves inspecting grounding electrodes, grounding conductors, and bonding connections throughout the electrical system. Any deficiencies must be addressed immediately. Thirdly, all identified electrical errors must be corrected. This includes rewiring miswired connections, replacing damaged wiring, and ensuring that all electrical components are properly sized and installed. It is essential to follow the National Electrical Code, or NEC, to ensure that all work meets the highest standards of safety and quality. Fourthly, the electrical panel must be thoroughly inspected and upgraded as necessary. The electrical panel is the heart of the electrical system, and it must be able to safely handle the electrical load of the house. If the panel is outdated, undersized, or damaged, it should be replaced with a new panel that meets current NEC standards. This may involve increasing the amperage rating of the service entrance, adding new circuit breakers, and ensuring that all wiring connections are properly tightened. Fifthly, all branch circuits must be tested to ensure that they are functioning properly. This involves using a multimeter to measure voltage, current, and resistance. It also involves using a circuit tracer to identify the path of each circuit. Any circuits that are found to be defective must be repaired or replaced. Sixthly, all electrical fixtures and devices must be inspected to ensure that they are in good working order. This includes checking for loose connections, damaged wiring, and faulty components. Any fixtures or devices that are found to be defective must be repaired or replaced. Seventhly, all smoke detectors and carbon monoxide detectors must be tested to ensure that they are functioning properly. These detectors are essential for protecting the occupants of the house from fire and carbon monoxide poisoning. Any detectors that are found to be defective must be replaced immediately. Eighthly, all electrical work must be properly documented. This includes creating a detailed record of all repairs, upgrades, and modifications that have been made to the electrical system. This documentation will be valuable for future maintenance and troubleshooting. Ninthly, a load calculation should be performed to determine the electrical demand of the dwelling. This calculation will determine if the existing service and panel are adequate for the connected load. The NEC provides guidelines for calculating electrical loads. Tenthly, consider the age and condition of the existing wiring. Homes wired with older methods like knob and tube wiring or aluminum wiring may present significant safety hazards. Knob and tube wiring lacks a grounding conductor and is prone to deterioration over time. Aluminum wiring, especially smaller gauge wiring, has a higher resistance than copper and can overheat, leading to fire hazards. A complete or partial rewire might be necessary to address these issues. 11thly, pay close attention to any signs of water damage or moisture intrusion. Water and electricity are a dangerous combination. Any electrical components that have been exposed to water should be inspected and replaced if necessary. Identify and address the source of the water leak to prevent future problems. 12thly, ensure proper GFCI or ground fault circuit interrupter protection in areas where water is present, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to quickly interrupt power in the event of a ground fault, preventing electrical shock. 13thly, arc fault circuit interrupters, or RFCIs, should be installed to protect against arc faults, which are a common cause of electrical fires. ASIs are designed to detect and interrupt dangerous arcing conditions in wiring. 14thly, when replacing or installing new electrical fixtures, choose energy-efficient options such as LED lighting. This will reduce energy consumption and lower electricity bills. 15thly, consider the future needs of the occupants. Are there plans to add new appliances or equipment that will require additional electrical capacity? It's wise to plan ahead and ensure that the electrical system is capable of meeting future demands. 16thly, ensure all work conforms to local electrical codes and regulations. Contact the local building department to obtain any necessary permits and inspections. 17thly, communication with the new owners is essential. Explain the scope of the work, the potential challenges, and the importance of addressing all identified electrical issues. Keep them informed throughout the project and answer any questions they may have. 18thly, remember to de-energize circuits before working on them. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. 19thly, avoid overloading circuits. Overloaded circuits can overheat and cause fires. Check the amperage rating of the circuit breaker and ensure that the total load on the circuit does not exceed that rating. 20thly, use the correct size and type of wire for each circuit. The NEC specifies the minimum wire size for different circuit types and amperage ratings. 21stly, ensure that all wire connections are properly made and tightened. Loose connections can cause overheating and electrical arcing. 22ndly, protect wiring from physical damage. Run wiring through conduit or other protective enclosures in areas where it is exposed to damage. 23rdly, keep electrical panels and equipment accessible. Do not block access to electrical panels or equipment with furniture or other objects. 24thly, educate the new owners about electrical safety. Teach them how to identify potential hazards and what to do in the event of an electrical emergency. 25thly, be aware of any existing knob and tube wiring in the house. Knob and tube wiring is an outdated and potentially dangerous wiring method. It should be replaced with modern wiring. 26thly, check for any signs of aluminum wiring. Aluminum wiring was used in some homes in the 1960s and 1970s. It can be a fire hazard if not properly installed and maintained. 27thly, inspect the service entrance cable for damage or deterioration. The service entrance cable is the cable that brings power from the utility pole to the house. 28thly, make sure that the electrical meter is properly grounded. A properly grounded meter helps to prevent electrical shock. 29thly, check the grounding electrode conductor for corrosion or damage. The grounding electrode conductor connects the electrical system to the earth. 30thly, verify the presence and correct installation of surge protection devices, or SPDs. SPD protects sensitive electronic equipment from voltage spikes and surges. 31stly, carefully inspect all junction boxes to ensure that they are properly covered and that all wire connections are secure. 32ndly, pay attention to the placement of electrical outlets. Outlets should be located in convenient and accessible locations. 33rdly, consider installing tamper-resistant receptacles, or TRRs, especially in homes with young children. TRR prevent children from inserting objects into the outlets. 34thly, ensure that all electrical work is performed by a qualified and licensed electrician. 35thly, do not attempt to perform electrical work if you are not qualified. Electrical work can be dangerous and should only be performed by someone who is properly trained. 36thly, when working with electrical tools, always use insulated tools. Insulated tools help to protect you from electrical shock. 37thly, never work on electrical equipment while standing in water or on a wet surface. 38thly, always disconnect power before working on electrical equipment. 39thly, when disconnecting wires, be sure to label them so that you can reconnect them correctly. 40thly, when replacing a fuse or circuit breaker, use the correct size and type. 41stly, do not overload extension cords. Overloaded extension cords can overheat and cause fires. 42ndly, inspect extension cords regularly for damage. Replace any extension cords that are damaged. 43rdly, keep extension cords out of high traffic areas. 44thly, do not run extension cords under rugs or furniture. 45thly, use the proper type of extension cord for the application. 46thly, when using power tools, follow the manufacturer's instructions. 47thly, wear safety glasses while working with power tools. 48thly, keep your work area clean and well lit. 49thly, take breaks when you are tired. 50thly, if you are not sure how to do something, ask for help. The combination of meticulous planning, skilled execution, and a commitment to restoring the electrical integrity of the property will transform this hazardous house into a safe and functional living space for the new owners. The first step to correcting the problem is to get the power turned off to the entire building so that the troubleshooting can begin. Next, it is time to begin mapping out circuits and discovering where all of the problems lie. In a structure this old, there are sure to be many. After the problems have been found and documented, it is time to come up with a game plan with the new homeowners. The electrical panel or panels may need to be replaced and relocated to bring them up to current codes. And some or all of the existing wiring may need to be replaced as well. A time and materials billing arrangement will be the best way to accommodate all of the unforeseen obstacles that are sure to arise. It will be a long and arduous process, but the new homeowners will certainly appreciate the effort and the peace of mind that comes with having a safe and reliable electrical system.